guys, so today we're gonna do some assemblies. I think assemblies are super cool. There's a lot of really neat things you can do. Today we're just gonna kind of keep it simple and we'll see how it goes. So I'm gonna do two different assemblies. So this first one we have is just a little piston. So we have our base part, we have 5 components total. So we will just walk through how to put that together. Couple things to note when it comes to assemblies. We want our origin to be wherever it tells us. So assembly origin as shown, it's right here. So I need to make sure that the origin of my assembly is at this point on this yellow block. So back to SolidWorks, I'm going to start a new assembly. That's the one with this little blue block on top of it as well. So I'll hit OK. And then, so when you open a new assembly, it's like, oh, okay, what do you want to put together? So I'm going to go to my piston. I'm going to just select all of them and hit open. And when it first comes up, it's just kind of stuck to my mouse. So I'm just going to click and place things and we will deal with it later. Okay, so there we go. We did it. Step 1, done. Next, notice how I'm already in IPS, which is what this problem told us to be in. And then the other thing we need to notice is everything came in with a little minus sign next to it, except for this one. See, when I try to move it, it said the selected component is fixed. This isn't what we want to be in place. We want this one to be in place. So I'm going to right click and float my long arm. So now I can move it and it's totally fine. Now, I don't just want to fix my base because I need my origin in a specific spot. So notice when I click the origin of my entire assembly, it's right here. So I'm going to go ahead and move this one just out of the way. So a kind of neat thing about assemblies, at least I think it's kind of cool. So the assembly itself has an origin and 3 planes. But then each part also has an origin and 3 planes. So it works out quite nicely. So just to make sure that I'll get everything in the right place. So we have our base with the little knobby there and the origin down here. And lucky for us, that is exactly where the origin of the base part is. So the way you do pretty much everything in an assembly is using this lovely mate button up here. I have no idea what's going on up here. Oh my gracious. Okay, that looks better. So I can either select mate and then select my origins, but when it comes to origins, I like to select them first. I'll select both by holding Control or Shift, and then I will hit mate. And SolidWorks is kind of smart sometimes, and it already knows that I want these to be coincident, and then I also want these axes to be aligned. So I have my, oh wait, do I want them to be aligned? Y, Z, oh, I'm sorry, X, Z, Y. So let's look at what we got. We have X, Z, Y. So that is in fact not how we want it to be aligned. So I'm going to make sure that my align axes is not selected. And then I've already forgotten everything. Yeah, we want Y going where our Z is at the moment. Okay, see, this is why you got to pay attention. So I will go ahead and make these coincident, and then I can, so it's just stuck on this point. I can move it however I so desire. So if I want, I'm going to forget everything. X is up, Z is this way. Basically, I just need to go floop. So I can use my planes. Planes come in handy. So if I want it to be, Sorry, sometimes I have to like move it to figure out how exactly I want this to be oriented. So we want it this way, but we want the part to be this way. Sometimes you just have to do some weird stuff and it'll work out. So my part, oh goodness, I did not mean to do that. Within my part, I want the planes of my part. Oh my goodness. There they are. So I want my front plane to be coincident to the, looks like, top plane. There we go. I'll hit OK there. And then I have to do one more plane to make this fully defined. So let's do right plane with front plane. There we go. Okay, so now this should be fully defined. I don't have to do the other one just because the other plane, I'm sorry, because we have a point and then 2 planes. We don't need to do 3 planes. That is a little overkill. We could do 3 planes and not the origin, but I think it's easier to start with the origin. Anyway, so now our base is done and it is correctly aligned. This does matter because it's asking us for a center of mass. And so if we don't have everything lined up correctly, we're not going to get a correct center of mass. So anyways, we're just going to put all this stuff together, and then the last thing we'll do is put this little distance in. And yeah, so here we go. So we're gonna start with this little pink one. So I'll go grab mate again. And when you're dealing with circles or cylinders, I'm going to select the face and make them concentric. So that means that the center of their circles, the center of each circle is the same. So now it can move, but this circle has to stay in line with that one. So, but I don't want it to be able to move everywhere. I want it to be stuck onto this face. So I will select the faces I want to be touching and they will be coincident. Okay, so that one's done. Then I've already forgotten everything. Then we want this piece there, that one there. Okay, beautiful. We can do that. So cool. I will select the inside face. Not that there's an outside face, but I will select some faces. Try to use faces and not edges when it comes to assemblies. I think it just makes things work out a little better. And sometimes it doesn't like edges. So there I made these 2 concentric and then this face and this face coincident. So next, let's see. So we can tell by our picture that our blue part is right in the center and it comes all the way to the end. So let's do that part next. So I like to kind of move things to the correct orientation and then mate things. I do not want this face, so we will clear that selection. Okay, so I know I want this face and this face to be coincident. And then I want this face and this face to be coincident. Notice how just because I've made something coincident, it doesn't mean it has to be touching. It just has to be like their planes have to be the same. Like if I'm, how do I explain this? Like if I were to sketch this, okay, I could use the same plane to sketch both of those things. Of course, I'm not going to do it, but that's kind of the same idea. Like just because you make something coincident to something else, it doesn't mean it has to be exactly touching that particular area. Alrighty, so now we need this thing right in the middle. there's quite a few things we could do for this one. One, we can look at our planes here. So see, that one's not going to work. That one's not going to work. That one's not going to work. We can look at the planes within each shape. So once again, none of these will work. Oh, I'm sorry. I didn't mean to do that. I don't know how I did that. Crazy. Okay, so none of our planes will work. So that rules that method out. But we got some kind of fancy mates here. So we can do mate. And instead of using our standard mate, we can use an advanced mate. And we will use width. Now let's see if I can actually remember how to do this. I always forget. Sorry, I forgot every single thing I know. So had to take a quick little break to reorient myself, but we're back. Okay, so we're going to use a width mate, which will center things nice and pretty for us. So for width selections, that's basically going to be where I want this to, what in the world, where I want this to be centered about. And so I have chosen both sides so that it is this distance. And now for my tab selection, I will select both of these sides, and you can see it moved. So now it's nice and centered. Okay, so that mate is, it's a little weird. Obviously, even I forgot how to do it. I also recommend the symmetric mate, or you can also add a distance mate. You would just have to measure this distance and this distance and do some math. But either works, either is totally fine. But now this part is fully defined and it cannot move. So there we go. That's what we want to see. I cannot move this. Oh my goodness. Okay, there we go. Oh my gosh. Okay, we're making it work. Things are being a little finicky today. It's okay. We're doing great. So for this one, we want this piece, maybe. Oh my goodness, I cannot select things today. And this piece to be nice and concentric. Then we also want this piece and this piece to be concentric. So there we go. And that should be, yeah, so now we can see this little piston moving nice and pretty for us. So we can move this back and forth. Beautiful. Maybe. There we go. It's moving, it's working. Okay, so last thing we need to do is add in this little distance here so that we can get our center of mass. So it's telling me my x distance is 3.5 inches. Now, notice, I cannot see back there. That's the problem, right? So I'm going to go ahead and use a section view. So now I can see what's happening inside, which is good. So I will choose mate. I will go this face and this face, but I don't want them coincident. I want them to be at 3.5 apart from each other. I'll hit OK, and then I'll get out of my section view. Now notice I don't have any of the little minus signs in front. It is all fully defined. So last thing I need to do is go evaluate mass properties. And I don't know why this is still being forever weird. But here is my center of mass that I would report. So this assembly is done. I'm not going to save this actually. So if we move on to our next question, it says modify the distance x to be 4. And then this time it doesn't want the center of mass, but it wants this angle from our base part to our pink part. So if we go back, modifying super easy. I can just look under mates. If I have a lot of mates, I could look under my individual parts and find the mates that way. For example, underneath my cylinder, I have mates in assembly 1, and that list is much shorter than the other one. So I just right click, it's like editing a feature, and then I will just change my 3.5 to 4 and hit OK. And then it wants to know an angle. It wants to know the angle between here and here. So I'm going to use my handy dandy measure tool. I will select this face and this face. And my angle is 71.35 degrees. If you're not sure really how the measure tool works, you could also just start to do a mate. So you would select this face and this face, and then you can look under the angle mate and you will see that it is 71.35. I think measure is easier because sometimes if things are not fully defined, it can move stuff around. And you'll ultimately get an incorrect answer. Moving on to our final question. This is our mechanism assembly. Our units are millimeters, grams, seconds. Our origin is going to be in this bottom corner here with a normal X, Y, Z axis, which is nice. We don't have to change that around this time. And then we want this little blue block to be an X distance away. So we will come back to that X distance here in a minute. First, we're just going to focus on getting our yellow part constrained to our origin and then get everything else together. So we are going to start a new assembly again, and it's going to pop up asking us what we want to put in there. And I will go back to my desktop mechanism and grab all of them. I could also do one at a time, but this way is much easier. Just place stuff places. So the first thing that you place is always the thing that's fixed. So I'm going to go in and float that block. And then I'm going to, well, first I'm going to move that out. It doesn't really matter. It's a personal preference. I'm going to do, oh no, I need it to be in this corner. Notice that. Sometimes you can't choose the origin. That seems like a really weird place for an origin, but we'll take it. Oh no, it's just the center of those holes. Never mind, it's not that weird. So I'm going to select this point in my origin of my assembly, and I will mate those together. Notice I don't have an align axes anymore because I'm not mating two origins together. I am mating an origin and a point. So I am going to have to go in and mate a front plane and a front plane. And let's do a top plane and a, why do they keep disappearing on me? Top plane and a top plane. And we'll just make them parallel because obviously they are not touching each other. And we want this to be our origin. So now this part should be nice and fully defined, which we know it is because we don't have the little minus sign in front of it. And also we can move it. Just to double check, here's our origin. That's what you want. So let's get this show on the road. So we want our blue part connected here. We want our red one here. All right, let's do it. We're just gonna crank out some mates. So we got a nice concentric mate here. we'll do this face and this face. There we go. Beautiful. That moves nicely. Okay, so now we have this one and this one, nice and concentric. Okay, and then we have here to here. Beautiful. We have our block is going to be here, coincident. And then we also know the bottom is going to be touching that one. Then we don't yet know a distance. So we're getting pretty close. So our block can slide, our wheel can turn. Now, how in the world am I supposed to put the mate between the slots and the little knobs? So I can't do concentric. So what do I do? Well, let's see what SolidWorks tells us. So first, I can select things and hope that SolidWorks will tell me something. Let's see, so it's saying, oh, you can make this tangent, but it's on the outside. We don't want it to be on the outside. So I can go hit flip mate alignment, and now it is nice and on the inside. Is that what I want? Let's see. Sorry, I'm not selecting things well. I honestly have no idea how this is supposed to move. So let's see how it goes. Sometimes things don't move right until everything is dimensioned right, or not dimensioned right, mated properly. Okay, so if I move this block, oh yeah, there we go. There we go. That seems to be better. Okay, so I just used a lovely tangent mate. There we go. There's also definitely a mechanical mate you could use, but we're not that advanced yet. So I will just show you the nice little basics. And we're gonna have this block 80 millimeters away from the side. So I'll go mate this side to our block. We don't want them coincident, and oh, I did that. Okay, so I'm just gonna go ahead and hit 80 millimeters. And then I'm gonna change this. Don't do this. This is bad. And then just to make sure that it is actually correct, I'm going to edit this, and it should hopefully say 80 millimeters. Okay, we are good to go. We did it. This is it. I don't remember what it's actually asking for. Is it asking for anything? Oh, report the Y component of the center of mass. So we just go evaluate mass property. Oh, and there's our Y component. So this is it for assemblies, at least for today. I might do some more advanced stuff later on. But the most important things are checking where your origin is, checking how things are aligned. As we saw in our first example, our z-axis was the one pointing up instead of y. So always check that. That's the first thing you want to do, is mate your origins, or an origin and a point like we did in this particular one. So yeah, there's a lot of really neat things you can do with assemblies, but when it comes to like the CSWA or homework, make sure that your origin is in the correct spot. And yeah, other than that, it's fairly straightforward. Cylinders and cylinders are concentric. If something is touching something else or in line with something else, it's going to be coincident. And then you can also use parallels and perpendiculars to make things not rotate. Oh, that's something else I was going to say. Location of holes matter when it comes to like reporting center of mass. If I had, let's see here. If I had a pin on top of something, then the hole would need to be in the correct orientation. I really messed that up, but it's a Sunday. It's okay. We're rocking it. I hope you found this at least remotely helpful, and I'll see you next time.